Welcome to section 2.1. We are going to talk about relations and functions today and what does it mean in terms of the different methods that we're going to use in Algebra 2. So here's what we're going to do. We're going to start with the basic idea of a relation. A relation is a mapping or pairing of input values to output values. Now, what that really means as you're looking at it is what it says is there is a relationship between our inputs or our x values and our outputs or our y values. And so we're looking at a relationship between the two. Now, the first way that you normally see these relations represented is in an ordered pair. Now, in that ordered pair, I could just write an ordered pair, or I could put it in the table. And so what I'm going to do is, for an x value of -2, I have a y value of +2. So I could take an ordered pair and put it in a table. I could also put that ordered pair on a graph. And so to put -2, 2 on a graph, I would go left 2 and up 2, and I get this point -2, 2. The third way, or the fourth way to look at it is a new way, okay? And this is called a mapping diagram. But I love the mapping diagram, even though it's new, to help us talk about our next definition, which will be a function. And so what I'm going to do is for an x value of -2, I'm going to draw an arrow to its y value of +2. And all that says is this -2x is tied to the +2y. Okay, now I'm going to take a couple of other things that we know on here. Let's do it this way. I have this point in my table, -2, -2, so it's here in this table, and I'm going to make it an ordered pair, so -2, -2. I could also put that on a graph, so go left 2, down 2. I could also put it in my mapping diagram. Now you'll notice between these 2 points here, they share an x value, which means I'm not going to rewrite my x value. Instead, I'm just going to draw an arrow from that x to a new y of -2. Okay? Now, before I go farther, this arrow pointing to the 1 should have a 0 attached to that. So it says from 0 to 1. I just want you to know that because I don't know why it didn't copy. So let's keep going. So I started with an ordered pair. Now I started with the table values. Now I'm going to go to a graph. I've got this point right here, which is the point, let me count, 1, 2, 3, up 1. So if this is the point 3, 1, then I'm going to go from 3 to 1. And then I'm also going to put it in my table. So an x value of 3, a y value of 1. It's already on my graph. And lastly, we're going to put it in our mapping diagram. Now, since the 1 is already there as a y value, I'm just going to put the 3 here and draw an arrow to the 1. Okay, last but not least, we have on this mapping diagram from 0 to 1. What that means is that you will have a point 0, 1, which is in the table. 0 is the x value, 1 is the y value. I could plot it, so I start at 0, I don't move left and right, so I move just up 1. And then it's already on my mapping diagram. Now as I look at it again, I don't know why this worked in the notes, but I'm going to cross this off because I don't have that 0 tied to anything, so it's not necessary. Okay? Now as we look at it, we're going to introduce a couple of more items too. Domain is the set of all input values. So it's the things we put in, which we called the x values. The range is the set of output values, which we know are the y values. So we put in an x, we get out a y. Now, for this relation right here, which we used 4 ways to represent, I want to give you domain and range. Now, here's the problem. Because they are only specific points, I'm going to use these braces, and these braces will help me tell which values are the inputs. What's cool about this is you can look at this first part of our mapping diagram, and this is the x values or the inputs. So what are they? Well, -2, so -2, comma, 0 and 3. And I'm going to close my braces. So we are just listing the x values that we see at this point in time. Okay, now our range is the output values, which if you look, that's these values here. Those are my outputs or my y values. So I have 3 y values, 2, -2, and 1. So I'm going to list them, 2, -2, and 1. Now, I prefer to list them in order. However, some teachers will disagree with that. So I'm going to leave it. If they're in order, great, from lowest to highest. If not, I'm okay with that too. And so we're asking you to be able to do these 4 methods: ordered pairs, table, graph, and mapping diagram. The mapping diagram I am going to ask that you do on a quiz or a test so that I can see as you're looking what those arrows represent and do you know the correlation between the x and the y. Okay? Now, I'm going to move this up and we're going to look at our second definition, which is called a function. Now, you did this in Algebra 1. It was a long time ago, so let's go back through. A function, by definition, is a relation, okay? And we did relation above. It means that the x's and the y values are basically tied together. Here's the important. For which each input value, okay, or if you want to put underneath, x value, has exactly one output value. And again, if you want, because for me, I like it the other way, I'm going to say y value. So there are a couple of different ways to actually say this, but by far, this definition you have to know. A function says that for every x, you have exactly one y. Or for every input, you have exactly one output. Okay? Now let me show you what that means in terms of a mapping diagram. What it says is that for the x value of 2, I should only have an arrow going to one y value. For the x value of 1, I should only have one arrow going to the 0. For the 3, I should only have one arrow going to a y value. And for the 6, I should only have one arrow going to the y value. And the idea is each x only goes to one y. Because we had one arrow coming off each number, we can say that yes, this is a function. Okay, and I would say yes because, I'm going to short this, each x has only one y. That's the easiest way, definition-wise, to talk about a function. Now let's go over and look at b. We're going to say the same thing. For -2, I have one arrow going to a y. For 1, I have one arrow going to the y. But for 2, here's our issue. We have 2 different outputs for the same input. That can't happen in a function. So no, not a function. And I would say something like, because 2 has two different y values. Okay, and I'm trying to fit that in. 2 has 2 different y values. Or you could say 2 goes to both a +2 and a -2. Something like that where you're looking at it this way. Okay. Let me move this up. Let's try another way to determine a function. Because let's be honest, not all the time will I give you a specific set of points like I did here, and it's easy for you to make a mapping diagram. Most of the time, we're going to look at it in terms of actual graphs, and so we want to look at that. The vertical line test says a function exists if and only if no vertical line intersects the graph at more than one point. Okay, here's what it means. If I can draw a vertical line anywhere on the graph and I touch it more than once, if I touch my graph more than once, it's not a function. So what I would do if I were you is kind of put in parentheses, can't touch graph more than once. Okay, if you want it to be a function, you cannot touch the graph more than once. That's the idea of the vertical line test. Now, what I would do as we start to get comfortable with this is I would just kind of draw some vertical lines. Yep, here only touch once. Yep, here only touch once. Yep, here only touch once. Here only touch once. You can see that as I go through and draw all these vertical lines, the idea is I'm never going to touch anything more than once. So I say, yes, it's a function. And I would say something like, because it passes, and we shorthand vertical line test to say VLT. Okay, let's look at number 2. If I look at the second one, I can go like this, and we're kind of showing you the line. And the problem is I touch it at the top and at the bottom. So this is not a function. Okay, third one, let's take a look. Well, I could draw a line through this point, I only touch one point. A line through this one, only touch that point. Only touch, only touch, only touch, only touch once. So yes, this is a function. Okay, fourth one, let's take a look. I could draw a line here, I only touch once. But here, I touch twice, so this is not a function. The vertical line test is so nice for us because, let's be honest, we don't want to have to draw this mapping diagram, and we can't because along these curves there are infinitely many points. So unless they give you specific points like these ones here, like these last two, I could do a mapping diagram with if I wanted, if you like the mapping diagram easier. The only problem is, again, if I give you a parabola or a sideways parabola or something, you are not going to be able to do it that way. Okay? Now, let's try the next one. If I take the ellipse and I draw a line, the problem is it touches more than once, so this is not a function. Okay? What about this one? If I cross here, I only touch once. Here once, here once, here once. The answer in this case is yes, this is a function. And the final one, once, 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 once again, this is yes, this is a function. Now, some of you might be saying to me, but Mrs. Szczepanik, and let me change my color so you can see it. You might say to me, but look at, ooh, right here I crossed more than once. And the answer is it looks like it. However, if I were to take my graph and basically get it to be really, really, really zoomed in, you would find that it always continues to look like this. And it never does actually go vertical. It gets closer and closer and closer to 0 but doesn't touch. And every decimal, this might be, you know, like a 0.01, and this might be a 0.001 and a 0.0001. It's always changing, but it just looks like it because of the graph that we have. Okay, so that's the first part of what we're doing. I want to move on and look at the second part then. So flip your page. All right, in the second part, we're talking about graphing lines. And this entire chapter really talks about graphing, and we want to get in the linear model. Okay, so an equation of two variables. Basically, most of the time, our two variables are going to be x and y. So you might see something like this. Y equals 3x plus 6, or you could see something even bigger like y equals 2x squared plus 9x minus 4. I can have as many terms as I want as long as I only have two variables. Okay, now our graphing calculators are going to help us with some of this stuff. So if you have a graphing calculator, pull that out. If you don't, I'm going to try and help walk you through how to do it without. Okay? The input variable, the variable we plug numbers into, we call the independent variable. And the reason it's independent is because we can pick any number we want. It doesn't depend on anything. And normally our independent variable is x because I can plug in any value of x I want for these equations above. The output variable is called a dependent variable, and it's dependent because the value of y, in this case, depends on what I plug in for x. And so the variable that you end up kind of solving, you know, or evaluating, I'm trying to evaluate y by plugging in x, is called our dependent variable. Now, the ordered pair, x, y, we consider that a solution. So I plug in an x, and I get out a y, and I can write that as a point. The graph of these equations in two variables is the set of all points that are solutions. So I can decide which points work and then make a graph based on that. Okay, now, if you don't have a graphing table, a graphing calculator, I apologize, you are going to have to make a table. Okay? If you have a graphing calculator, you can put your equation of y equals 2x plus 1 into your y equals menu, and that's on the top left-hand side of your calculator. Okay? Now, when we graph these, what we're going to either get in this chapter is a line, which we like better, or a curved graph. And I'm going to say curve instead of putting a name to it because, truthfully, I don't know what kind of curve I'm going to get. So, here we go. If I don't have a graphing calculator, I'm going to make a table. Most of the time, I'm going to pick three to 4 points, something like that, to make it work. And I always try negatives, zeros, and positives. So I'm going to go -1, 0, and 1 for right now. You have to plot at least 3 points, okay? Keep that in mind. Plot 3 points. That's important because I need 3 points to determine is it a line or is it a curve? And if it's a curve, I'm going to need more points. Okay, so here I go. If I plug in a -1, 2 times -1 is -2 plus 1 is -1. Okay, 0, 2 times 0 plus 1. 2 times 0 is 0 plus 1 is 1. 2 times 1 is 2 plus 1 is 3. So I can take these points. If I moved left 1, down 1, I get this first point. If I stay and move up 1, I get the second point. And if I move over 1 and up 3, I get this third point. Now, if you look at this, this seems to make a line. So in this case, we get something that's linear. Now, the questions we want to talk about are things like domain and range, and this is hard. I'm going to start actually first, though, with a function. If I try the vertical line test, is this a function? And the answer is yes, because it will pass the VLT. Okay, it passes the vertical line test. I could put all of these lines in there, and I'm not going to do it because I want to screw up our graph, but I could put all these lines in there and see that it works out. So let's talk domain. Domain is the x's. Is there any number that I can't put into the x and still get an answer? And what that basically means is there an x value that if I plug in, I won't get a point on my graph? The answer is no. These arrows mean it goes on forever and ever and ever. And so we say all reals, all real numbers. Now the shorthand for that is a double bar R. Okay, and that's the way to kind of shorthand it if you're interested. I'm going to shorthand it, okay? For the range, the same question. If I can put in any number, do I get any number out? Well, as I look, I have numbers that are negative. I have a number that is 0 right here, and then I have the numbers that are positive. If I can say yes to all 3 of those, then my range is all reals as well. And domain and range, in my opinion, are the hardest part of algebra, and so we're going to be working on that together. Okay? Last section talks about whether or not a function is linear. Now, linear has the form, and if you can remember back to Algebra 1, what's the equation of a line? It's y equals mx plus b. Here's the most important part. The x value is always singular. So you don't have an x squared, you don't have an x cubed. It's always a single x, okay, which means the exponent is 1. If we write it in function notation, and function notation is the hard part, instead of saying y, we use a function of x equals mx plus b. And what that means is if I plug in an x, I get out something where I plugged in an x, okay? This is what it says. You plugged it in using x. That's what it means. So my ordered pair is I plug in an x, I get out an f of x. F of x is exactly the same thing as y, but we want to start to switch your notation a little bit. Okay, now here's how it works. I'm going to give you this function, 2x cubed plus 6 minus x. And I'm going to evaluate x at negative 4. So I'm going to say f at negative 4 equals, and I'm going to replace every x with a negative 4. Plus 6 minus negative 4. Okay? Now, our first question, is it linear? The answer in this case is it's not linear because of the cubed. Okay? Now, even though it's not linear, I still want you to plug this in. Now, this f of 4, I'm going to draw a line down here because I don't want you to touch this left side. I want you to just evaluate it. So if you can, put your finger over the f of negative 4 and forget about it. We want to evaluate using order of operations. Okay, 2 times negative 4 cubed. Well, I do negative 4 cubed first. So I have 2 times a negative 64 plus 6, and subtracting a negative means plus 4. So 2 times negative 64 is negative 128 plus 6 plus 4. Addition means you can do them all together. I end up getting negative 118. I don't care about this left-hand side anymore because what does this just say? That's my y value. And what did I do? I plugged in x is negative 4. Okay, so let's try one more. Is the second one linear? The answer is yes because it's a single x. So I'm going to plug in g of negative 4. And what that means is I'm going to plug a negative 4 in for x. And then I'm going to forget about this because this is really just y. So y equals, well, 4 times negative 4 is negative 16. When you add 9, you get negative 7. Okay? Again, this only means I plug in a negative 4 into my g equation. That's all it means. And the hardest part, again, is notation. So that's the end of section 2.1. We are going to work on this in class a little bit tomorrow. And then we're going to start working in section 2.2 on slope and lines and things like that, which I know you have done in geometry. So it should be a nice review section for us.